Hello, good morning. This is Nas from NB Network Lessons. Hope you guys are doing okay. Today's topic of discussion is circuit analysis, lesson number 19, and I'm going to try to explain you what does an impedance means, okay? I'm sure you've heard, in your circuit analysis class, you have used impedance. But what exactly does impedance means? I'm going to try to see if I can summarize that and present that to you, that you can engrave that in your brain and remember it. Okay? So let's go ahead and get started. So anytime, what I have right here is sort of like a rows, and I have columns. In the rows, I have resistor, inductive capacitance, and inductive reactance, capacitive reactance, and so forth. So let's assume that you have basically, let's look at the component one, resistor. So let's say you have a resistor right here, right? And you are basically applying some voltage over here. And let's assume that that voltage is DC, right? So if you look at the output on like an oscilloscope or something like that, you will see that voltage, which is in red, is a straight line, current, which is a straight line. However, if I change this voltage source from DC to AC, okay, then when you monitor this on oscilloscope, you will see the red is in voltage, which is higher, in a form of a sinusoidal wave going like this. And then you have in blue is the current, which is less than voltage, but it's basically following voltage. And as you can see in blue, this is my current. Okay. So this is the nature of behavior informed when we have a resistor in the path. So how's that? Next, let's look at and see if there is inductor in a path. Okay, so let's say we have a voltage source, and this inductor only applies to AC. It does not apply to DC. All right, so let's say I have something like this inductor right here. What would be the output if you monitor this signal on oscilloscope? How would it look like on oscilloscope? If you look in here and your voltage source is AC, okay, I just want to make sure that you understand that this does not apply in DC. What you will see is that voltage would start right here in form of a sinusoidal wave, okay. However, the current is delayed, okay, and the current you can see had a delay in a start. In black right here, you can see the current delay. So this, my friends, is called inductive reactance. The component, which is inductor in this case, has the capability to basically lag the current. So current is behind the voltage. In this particular scenario, when we had resistor, current and voltage were moving simultaneously, even though they had different magnitude, but they're moving simultaneously. In this particular case, current is lagging. So how's that? All right, let's look at another scenario where you have a capacitor. Let's say you have a voltage source, plus, minus, all right, and you put a capacitor in between, right? So what would be the behavior if it's DC? If the source is DC and the voltage does not change, voltage is constant right here, your current would be zero. And that makes sense because there is no potential difference. In case of voltage, you have to have a higher potential pushing the current to lower potential. I remember my father, who was also an electrical engineer, when I asked him one time, how would you define voltage? And he said, well, voltage is like two wrestlers, one strong wrestler and one weak wrestler. The strong wrestler can create potential, whereas weak wrestler cannot create potential. So kind of like same analogy, basically what you have is that in this case, there is no potential difference. In other words, both the wrestlers who are fighting have the same capabilities. So you don't have any current, but you do have voltage. Now, let's say if we change the source to AC, let's look at the behavior. If you're looking at an oscilloscope, what we will see is that current starts first, okay? As you can see, current in red has started first and voltage is lagging, okay? So that is, my friend, known as capacitive reactance. So impedance in total, it is basically impedance which is equal to resistance plus inductive reactance plus capacitive reactance. So basically impedance tells you how a component in a circuit can change the output signal, the behavior of the signal. It can lag current, it can lead current, and so forth. So remember that if somebody asks you, hey, what is impedance? You can tell them impedance is basically, it's a way that how you can change the nature of how current flows in a circuit. So that's all I wanted to say. I hope you learned something. I enjoy always giving lecture to you guys. And if you like my contents, go ahead and give me a like. And also please share. Thank you so much for watching. You all have a wonderful day. Bye.